A mountain climber is rappelling down a vertical wall. The rope attaches to a buckle strapped to the climber's waist 15 centimeters to the right of his center of gravity. If the climber weighs 770 newtons, find the tension in the rope and the magnitude of the contact force exerted by the wall on the climber's feet. So first I solved for tension at the center of gravity. Tension equals mass times gravity plus mass times acceleration. And so I plugged in 770 for the weight of the climber times, divided by cosine 25, which gave me 850 newtons. And since the rope isn't attached at the center of gravity, we need to find out the center of gravity at the point that the rope is attached, which is at the buckle. So multiply 850 by 91 centimeters and divide by 106 centimeters. And the reason why I did that is because, as you can see in the diagram, the center of gravity is 91 centimeters from the wall, and the buckle is 106 centimeters from the wall. So the next step is to find the magnitude of the contact force exerted by the wall on the climber's feet. So the net forces in the x direction is 0. The force of the wall in the x direction minus t cosine theta is equal to 0. If I move t cosine theta over to the other side of the equation, the force of the wall in the x direction is now equal to tension times cosine theta. So I got I plugged in the 730 newtons from the tension in the first part, and I got my angle of 65 degrees, and once that was all multiplied out, I came up with 308.5 newtons, and for the force of the wall in the x direction. And so also the net forces in the y direction is going to be equal to 0. So the force of the wall in the y direction plus the tension of sine theta minus weight is going to be equal to 0. So the force of the wall in the y direction is now equal to weight minus tension times sine theta. So we have the weight of 770 newtons minus the tension of 730 newtons that I solved for, times sine 65, and I ended up with a force in the y direction from the wall of 108.4 newtons. And to find out the force of the wall in both directions, to find out the net force of the wall, the magnitude of contact force exerted by the wall on the climber's feet, I took the square root of the force in x direction squared plus the force in the y direction squared, and I came up with a force of 327 newtons.